So I've parked up for a bit, mainly because I love this area, which is Osborne House and Osborne Bay. And Harry, you might want to pan round to Queen Victoria's old house on the Isle of Wight. Beautiful location. Sometimes there's an ice cream boat in this bay, but unfortunately we've been unlucky today, so that's a thing. Anyway, so this segment, I'm feeling really narcissistic, by the way, just sitting here talking to a camera, but we'll put that to one side. This segment's really talking about what is known as a technology stack. And the reason why it's probably worth just understanding a bit about this stack concept is that the different layers all interrelate again. And again, I don't want to overcomplicate it. Technology can be quite complicated. The whole purpose of this is to make it simple. But there are different layers of technology that all interplay. So I've already mentioned software. You've got operating system, database, and application all sit on top of each other. And in the same way, the way IT is delivered these days is in a similar sort of stack. And each layer of the stack can fundamentally affect the rest of the stack. So let's start at the bottom. By the way, different people have got a different view on how this stack is structured, but so this is me talking about my view of the world. The bottom layer is what I would call data centers or facilities, and that is basically anywhere you store a computer. So that is like a room or a computer room or an office. It could be anything, and obviously it's pretty standard if you're buying facilities, you understand what that's all about. Things you need to consider specific to IT are if you're putting a lot of IT equipment into that room, it's going to use a lot of power, it will need a lot of cooling. So if you're buying data centers, specifically lots of servers in a place, you're going to need to consider all that stuff, all that sort of air conditioning and power consumption perspective. That's the bottom layer. And the reason why it's the bottom layer is every piece of hardware needs a home and needs a power socket. So that's always the bottom bit. The next layer up in my mind is networking. Now, most people use networking every day and they probably don't call it networking. And it ranges from your mobile phone. The networking in that regard is the connectivity from your phone to the either satellite or the local mast, and then onto the internet or wherever it's going thereafter. But that network layer connects the facilities, the data center, to the rest of the world. And so if you've got that networking layer correct, your computers will talk to the outside world or anything outside of its home correctly. So things to consider in terms of networking are bandwidth, how big it is, and speed sort of comes alongside that. There are different types of networking, like I said, mobile phones, satellite, copper cables in the ground, all sorts of things that you can do to connect your facilities to the rest of the estate. That networking layer sometimes doesn't sit within IT, by the way, from a procurement perspective. Personal preference, I think you should have it in there. Telecoms, IT, networking, they all go hand in my world, especially where you talk about things like collaboration software and that sort of stuff, which I'm going off down a rabbit hole. I'm going to stop there. Above the networking layer, you've got what I would call the compute layer. So, again, mapping it onto most people's understanding, that's your computer. That's the thing that's on your desk. That's usually a piece of hardware. Now, that in some cases is a device like a laptop or a desktop or your mobile phone. But in most cases for big IT implementations, that's servers. And those servers are big, powerful computers that run specific applications, which we'll come on to in a minute. And those are costly, expensive, difficult to get hold of sometimes, generally made in Asia, so the logistics of getting that compute layer in place, that can be quite difficult to ascertain. And so making sure you've got that designed correctly and the right technical solution is really key. And as sort of an extension of that compute layer is the storage layer. So now I mentioned previously in the hardware section, disk drives. That's really where you store your data. But anyway, I'm not going to get into too much detail there. Above that compute and storage layer, again, in my model, sits the sort of security layer. And that security layer is generally software, sometimes hardware, that protects all the stuff beneath it, the network, the compute, and the data center from external attack. So this is things like antivirus software, firewalls, things like denial of service or DOS attacks, distributed denial of service, I won't bore you with that. So DDoS and those sort of things. There's lots of different security as a whole segment in its own right. I won't bore you with that right now. But that security layer, it's really important to get that right. If you haven't got that, then you are leaving yourself open to attack. And on that basis, you could cause yourself a bit of a problem. The next layer above that tends to be what we call system management. So this is bits of software that are particularly good at managing IT. So this is monitoring software. This is incident management software, anything that controls your IT estate, software that typically runs your IT correctly. And then above those layers, I've already covered off, is database and application. So they're things that are actually doing a piece of work. So, storing information and delivering up an application such as email being a really common one, but also things like finance systems, HR systems, all those sorts of things. Now, the reason why I always describe it as a stack is because we're in a position where each of those layers will talk to each other. If you want to move data center, clearly all of the IT above it needs to go to the new place. If you change your networking layer, you've got to think about the implications on the data center, but also how it's going to talk to all the bits above it. All those things interrelate. And if you have got a holistic strategy for buying technology, you need to think about all those things as interrelated parts. Now that gets really complicated, and that's why you've got an IT team, but your technology procurement function needs to be cognizant of those dependencies, because if someone goes rogue and wants to buy a new data center, you need to ask the question, what's the impact on the rest of the technology estate? How do we actually do it? What's the migration strategy? Those sort of things. So I don't personally think procurement functions need to be experts in all things IT, but it helps asking the basic questions. And understanding that sort of diagram, that sort of stack layer, will give people a bit of an understanding of how things interrelate, and therefore, if you change one bit, what else needs to change? That is really my view of the technology stack. Massively oversimplified because there's loads of sub-layers behind it, and I've probably forgotten a few bits around the outside, but that's pretty much, that covers all things technology in terms of the way they sit on that stack.